we go. I think we're live. Hello, everyone. Welcome back to the second day of the second session of the second day of API Days Paris. This session is all about API identity management, and we're going to kick it off with Denis from Solo.io, who's going to be talking to us about advanced authentication. Welcome, Denis.
Hi, Jenny.
How are you? Yes, good. So we're going to get straight into it. So why don't you start with a brief introduction, let the audience know who you are and where you're coming from, and then the stage is yours, and I'll meet you back here in about 20 minutes.
Sounds good. Thanks.
And just a quick reminder to the audience. So feel free to send any messages, comments, and questions to Denis and any of the other speakers. So we hopefully have time for a Q&A at the end. Yeah.
Thanks.
Away, Denis.
So I am Denis Jannot. I am director of field engineering at Solo.io. So I'm going to speak about this advanced authentication pattern at the edge today. And before I'm doing that, I'm just going to go through like a few slides to explain, the main challenges there. And also at the end, I'll go through a live demo so that you see that in action. So obviously, everyone is trying to go from monolith to microservices. You don't learn anything in this slide, but that's just an introduction for the next slides, right? All these microservices, you tend to try to run them on Kubernetes. And one of the first things that you try to achieve after you deploy your services on Kubernetes is to expose them to outside so that people can access your applications. So at the beginning, you look at the different options, you find this Ingress option using like an Ingress controller like HA Proxy or Nginx, for example, and that works well. You can expose these services easily, you can do some basic routing, you can secure the communication with TLS. So that does the job, and that's fine. But at some point, you start to realize that you have more and more microservices in your cluster, and that each team is, needs to secure these services. So if they have like web applications, they try to secure them with OAuth workflows. If they are like APIs, perhaps some team will use JWT tokens, some other will use like API keys. But at the end, all these different teams, they tend to reinvent the wheel. They tend to spend time implementing these authentication, and the security team has no clue about what is implemented. So it's very opaque. If you want to make sure that none of your services are exposed without authentication, you cannot really do that easily. And you have to go through discussing with all the team to understand the way they have secured their applications. So it's not ideal. Also, you still need to implement some other mechanism, other security mechanism, like, for example, you want to apply some rate limits so that people cannot abuse your services. You want to implement web application firewall rules so that you can avoid some patterns like, I don't know, limiting the size of the body or these kind of things. And generally, this is implemented in an API gateway that runs outside of your Kubernetes cluster. And that's another challenge, because when you adopt Kubernetes, you try to put in place a modern CI/CD pipeline, based on GitOps, where you express in YAML the way you want to deploy your services, but you also express in YAML the way you want to expose these services outside. So the Ingress object, for example, in Kubernetes is the one you will use to define how you want to expose your services. But then when it comes to applying rate limits or WAF rules and so on, you cannot do that with YAML, because this is done outside of your Kubernetes cluster on this API gateway. So you have to basically ask a different team to set the rules for you. So it's really not following this logic of having everything fully automated with CI/CD and GitOps. So that's kind of a summary about the challenges I have just already expressed. I would just add that because all teams tends to re-implement the same things like this OAuth workflow and so on, they try to generally use the same languages and same frameworks so that they can share some code. But that's a challenge, because when you want to hire new people, sometimes it's easier to do that when you don't force them to use like a specific framework, right? It's really helps increasing the velocity of innovation if you give more freedom to your team so that they can use different languages. So what about using like a Kubernetes native API gateway? That's really what people try to do to solve all these problems. So when you have this API gateway running on Kubernetes, that means that now you can configure everything through YAML, right? So you can configure everything as code. It's not only you configure the way you expose your services, but you can configure the rate limiting rules, the WAF, and so on. And the other thing that you can achieve with this API gateway is being able to perform the authentication at the gateway level. So that instead of implementing the OAuth workflow or securing with API keys and so on at the application level, you can do that on the API gateway. And then you can configure your API gateway to extract some information that are useful for the application. Because now if the authentication is not done by the application itself, it means that it doesn't know by default who is the user. So what you want is you perform the authentication at the gateway level, but then you extract some information from the JOT token, for example, to indicate to the application who is the user that have been authenticated. It can be just like adding a header with the email of the user that have been authenticated, for example. You can still perform authorization in your application, but you could also do that in the gateway, and I will show you that in the demo. So multiple advantages that I will cover just after when you have this approach. But one thing I also want to highlight before is the fact that even if you run your API gateway on your Kubernetes cluster, that doesn't mean you cannot use it to expose services that are running outside of the cluster. You can still use it to expose legacy services running in VMware or bare metal server. You can still, you can even use it to expose services like modern services that you would deploy in Lambda, for example, in AWS, like using function as a service. So it's really like allowing you to cover the full scope between legacy, cloud native, and even like functions and things like that. So again, I went through multiple advantages already, but one that I want to highlight is really this visibility for the security team, right? Now that we configure all these authentication and security mechanism in the API gateway, the security team can go and look at the configuration of this gateway and have a holistic view of all the security that has been put in place to when exposing these services outside. Everything is now expressed as code, so it's GitOps friendly. The application teams can focus on the business logic now because all these security aspect is outsourced in this API gateway. So in Solo.io, we have this Kubernetes native API gateway called GLUAGE, which does exactly what I described. When we say Kubernetes native, it means that as I said, you can configure it as code. And it's not that you can just configure a few a few features that way. You can really configure 100% of it. That's a big difference compared to some legacy gateways that would do some Kubernetes integration where you could configure some of the functionalities as code, but then still some of them would be configured a different way. This API gateway is based on Envoy Proxy. So I don't know if you are familiar with Envoy, but it's a very popular proxy that is part of the CNCF, so the same foundation that is behind Kubernetes. And you probably also hear about Envoy when it comes to service mesh. And I will speak about it very quickly at the end, I think, if I have time. But what we see is that everyone is going through adopting like an API gateway today, but we also see that everyone has like a service mesh project, either right now or in the near future or even later. But I would say everyone would agree that they would need service mesh at some point. And these different service mesh options are based on Envoy. So if you need to choose an API gateway today, it's better to choose one based on Envoy because that will be the same technology that you will use for your gateway and for your mesh. And when you use the same technology, you can get the metrics in the same format, you can troubleshoot in the same way, and so on. So I think it's an important point. Obviously, the other advantage of Envoy is that it provides very high performance. It's written in C++. It can be driven by an API, right? It's not like a legacy proxy that you configure with a file, right? It's really designed to be configured through an API, and because it's part of the CNCF and it's not really driven by one company but by many, it makes it like a really nice neutral option. So the way Envoy works is that you have this notion of filter chain, so that basically when a request comes in, these different filters can modify the request, right? They can reject the request, they can add headers, they can modify headers, they can do many things. So basically, a request comes in. If you want to do authentication, like I described before, then you would use like what we call an authentication server. So either you would build your own if you would use like GLUAGE open source, but it's quite difficult to do, or you would use something like GLUAGE Enterprise that comes with its own authentication server, and then you could leverage all the options there, right? So you would have like a OAuth workflow, API keys, JOT, and many other options. So the request goes to this authentication server that decides if it should be accepted or rejected. Then it can go through the rate limiting filter that decide if the rate limit is reached or not. And then you can have also filters that runs directly into Envoy itself, like a web application firewall that is based on mod security. We don't need to contact an external component. It's really directly running in Envoy. As I said, Kubernetes native, everything has code, and you have like different CRDs that we use for that. And the virtual service, which is sometimes confusing because this is the same name that is used by Istio, if you are familiar with Istio, but this is like a GLUAGE virtual service where you can describe what you want to do, basically at the high level. Like I want to listen to this request coming for this domain that match, this prefix and so on. You could define all the routing there, but you could delegate that to another object called route table, which makes it like very nice because you can now have a team that is responsible for taking care of this domain. And then when the prefix starts by app1, I want to delegate the routing details to the team that is taking care of app1 so that they can write their routes as codes without having the full control of this domain, for example. You have hot config where you can decide how you want to secure your communication and so on. But I'll go through the demo, and I think it will be easier to understand when you see everything in action. So Miguel, if you don't mind, yeah, perfect. Switching to my screen. So I see that you should now be able to see my entire screen. So what I'm going to do, I'm going to go through like a demo using one of the lab of our workshops. Really feel free to go to, after my talk, to solo.io website. And if you go to resources, events here, you can see my talk here, but you can see also like that we do a lot of workshops, and you have like hands-on labs. We give you an environment where you can play with all these features. And in this workshop, we speak about like rate limiting and WAF and everything. But in that demo, I cannot show all of these things, obviously. So I'm going to focus on the authentication and authorization. So I spoke about different objects, right? So we have one that's called like a hot config that allows me to configure the way I want to authenticate my request. And what's nice is that because it's a separate object, I can configure the authentication there, and then I can call this, I can reference this object in many different routes, right? So I can define this config at the virtual service layer level, so that it applies to all my routes in my domain, but I could also decide to just apply it to a few of the routes. So that's give you, again, a lot of flexibility. And you can see this is an array. So generally, if I just want to do authentication, I would just provide this information here with all the information about my identity provider. So as you can see here, I'm using Keycloak, and I deploy Keycloak in my environment so that I will be able to use it as an identity provider. And you can see as well that I want to extract the JOT token and put it like in this header after when I finish the authentication. And I have a second step in my array that is performing authorization with OPA. So if you are not familiar with OPA, Open Policy Agent, it's a very nice way to perform authorization as code. And it has a language that's called Rego. And the Rego language looks like that. So basically here, what we say is that we want to allow the request only if the email of the user ends with @solo.io. So you see, to get this email, we extract it from the JOT token, right? So we authenticate the user, we get a JOT token from this in this JOT token, you have different claims. One of the claims is email, and we extract that to perform the authorization. And this Rego is just stored in a config map. So that means that, again, you can maintain everything as code. And then I have my virtual service where I can define what I want to achieve, right? So you can say, if I have like a route that starts by /, then I want to use this hot config, and I want to send a request to this application. And here, what I do as well is that I say, I extract this header. I will not use that in the demo, but just to show you that it can be, we can do like a lot of things. You could also extract some claims to write new headers. As I said, it's always important that you can tell the application who has been authenticated. So being able to extract these claims is very powerful. So I am already having access to my page here, and I authenticated with the user that's called user1 that has an email that ends with solo.io. So that's why I have access to it. But now let's see if I try to open a new incognito window. Don't know why it doesn't want to do it. Okay. I open this new incognito window. I am redirected to Keycloak because I need to authenticate myself. And if I authenticate with another user that's called user2, this user doesn't have an email that finished by solo.io. So if I click on sign in, then you see it is rejected, right? So very easy way to demonstrate this authentication. As I said, it's just one thing you can do with Glue. You can do much more if you go into this documentation here. You will see like it's quite easy to navigate in the documentation and see all these security mechanism. For just authentication, you have like, as I say, OAuth, API keys, OPA, LDAP, JOT tokens. You have rate limiting with a lot of advanced mechanism there that allows prevention, web application firewall, and much more. And you also have like a nice observability stack that comes with it. So I didn't generate a lot of traffic here, but you can see the control plane itself, right? How Glue Edge behaves, if everything is in sync with Envoy, and if there are like any error or things like that. You can also navigate into your backends and get some details about what's going on in a specific backend, right? Backend service, like the request time, or the response codes, and if you have circuit breaker that has been reached, retries, like a lot of very interesting data there. You could even like get some nice information about the XDOT, the authentication and the performance on it, and so on. So again, I don't have time to go through all of this. I could speak about it for an hour, but I don't have the ability to do that right now. But I really invite you to go to the doc and to continue the discussion with us later on, right? So Miguel, if you can just go back to the slide, if you don't mind. Yeah, perfect. So also just wanted to highlight that we have like also a developer portal that comes with GLUAGE Enterprise, that again is something you can completely configure as code. So it's quite interesting. I think it's quite unique in the sense that you can use it, configure as code, use it to expose your services on Kubernetes, but also on Istio. And the thing I wanted to finish with is really this fact that we discussed about how I can expose securely my services, but we didn't discuss about how can I connect these services securely, right? So you have all your microservices on Kubernetes, and you now know how they are exposed. The security team can have a good view of that in the API gateway, but still you have no clue about what's going on in your cluster. And that's where a service mesh can help, right? So you can have this Envoy Proxy, which is running in all the pods, that intercept all the communications, and that give you all the information you need about who's communicating with who, if it's encrypted or not. You can encrypt without having to do anything on the application level. You can define which service can talk to which service, and so on. So again, I think it's kind of the next step after you secure the way you expose your services. You want to secure also the way you connect these services. And we have also a solution there at Solo called Glue Mesh, where we give you like end-to-end Istio support, and allows you to manage multiple Istio clusters in a simpler way. Just like invite you to also join our Slack if you want to continue the discussion. I think we still have like 2 minutes for questions, so I try to keep that. I don't know how you want to do that, Janica, if you have selected one or two.
Yep. Yeah, that was great. First of all, thanks for the live demo. We love a live demo, and I think that was the first on this stage anyway today, so that was great. If you can just share the links that you showed in the conversation at the end, then people who are in the audience, well, you can do it later, but just so people have access to it in the chat afterwards. One thing that I wanted to ask you about from the developer perspective, because there's obviously nothing like learning from other people's mistakes. So what would you say are some of the common mistakes that developers do or make in this space of like implementing security or auth protocols?
Yeah, I don't know if it's a mistake or not. What I would say is that because basically they get some tools, either from the platform team or just by themselves if they deployed their Kubernetes cluster or whatever. But with this tool, like I say, like a standard Ingress, for example, you cannot do much on this authentication part. So you need to implement in your application, right? And that's not really a mistake. It's just that they don't have any other option. And generally, they are not the one who decide if they should have an API gateway or not, right? Generally, it's another team, like a platform team, that decide about it, right? So generally, several developers or several teams make the mistakes, or don't have any other choice than making this mistake, and then they start to complain to the platform team and say, "Hey, I'd like to have an API gateway because it will make my life easier." Sometimes it's the security team that comes in and say, "Hey, I want to have like a good view of what's going on," right? But I don't think it's a mistake. It's just that they do what they can with what they have, right?
Yeah. And I guess what would be the way out of it?
The way out is like, what we see generally, that So people put this API gateway in place, and then they don't tend to rework what already exists at the beginning because that's not the main priority. Generally, they tend to use it for all the new services. And then these new services work well. They start to kind of implement this security at the gateway level. And at that time, they can share with the existing team the way they did it. And then the application team can decide if they want to change their implementation to use the gateway, if they want to keep doing that in the application. And also it can be the corporate, like the security team, as I said, that say you need to implement it that way, right? But generally it's a gradual adoption. It's like service mesh. You put the service mesh in place, but at the beginning you have 0 services in the mesh. And then you start to move some of the services in the mesh, and you start to take advantages of this mesh for a few of the services, start to see the communication and so on. And at some point the adoption becomes higher and higher, and hopefully everything becomes in the mesh and you can get like the full advantage.
Yeah, it's like a journey that some of the other speakers said. Thank you very much. That was a great session. Thank you, Denis.
Yeah, sorry, I think I did something wrong with my foot. So
You're good.
So yeah.
Yeah, thank you. Have a good rest of the day. I think we're about to